Hi, this is Dr. Green. In this video, I'm going to show you how to complete Jamovi Part 5 on regression. So you're going to be working with this data file graduation. So it's a Jamovi file that is in the project data file subfolder on Canvas. So you'll open it up and you can see here 5 different variables. I'm going to have you looking at regression or correlations between year and percentage of honors, and then ACT and percentage of honors. So for an example, let me show you how to do regression with year versus number of grads. So first of all, we want to look at a scatter plot to see if it looks like these two have a linear relation. So if you click on exploration and you do not see scatter plot, then you need to add the scatter module. So you'll click the plus sign for modules over here, go to Jamovi library, and scatter is that first one. So this one says installed already because I already have it installed. If you don't have it installed, then you'll click to install that. So then you will go to exploration, click on scatter plot. You need to specify your X and Y variables. So our independent is going to be the year, and then the number of graduates will be our y-axis. And if you look here, it does look like there is a linear relationship. You can see that the data channels from lower left to upper right, with the exception maybe of, we got some data values out here that, possible outliers may be these two that seem far away from the rest of the data, and then, possibly this one here. But you can see generally with most of the data there is a approximately linear pattern. So then to generate the Anova, so I'm going to click on the data tab, go back to analysis. We want to go to regression, and then we'll come down to linear regression. And our dependent variable, again, for this example is number of grads, and then our covariate is going to be year. So that's your X variable. So you can see our linear regression here. It gives coefficient of correlation, coefficient of determination. So we see pretty strong linear correlation, 0.884. Remember, closer that is to 1, the stronger the correlation. And then it generated an Anova table here. So the intercept for our regression line is negative 30,720.5. And then the year, that's the slope coefficient. So 15.5x minus 30720.5 is our regression line. We see that the p-value for year is less than 0.001. So that means that this is a statistically significant relationship. Now to generate the Anova table for the regression, you will come down here to Model Coefficients, and then you'll click on Anova Test. And so here is the Anova for the regression. So generated our Anova table. You've got sum of squares, degree of freedom, mean squares, your F statistic, and then your p-value. This p-value, less than 0.001, should agree with this p-value. And they do in this case. So in the actual project, I'm going to have you write the line, use it to do a little bit of prediction, and then you're going to fill in your Anova table. Of course, the totals for sum of squares, degree of freedom, and mean square, those we'll have to do by hand. So if we skip back to the project here, you are going to do your 2 scatter plots, comment on whether you think there's a linear model, do there seem to be outliers, and then you're going to fill in your Anova table, and that's from this output. Totals in the bottom you get from the calculator, and then writing the regression line, again, that is from this output down here, model coefficients. So slope 15.5 and then y-intercept. So that'll be your M and B in MX plus B form. So, and then you're going to state the t-value and the F statistic, and along with the p-value for that. So your t-value, right here, it's the t-value for slope, and then the f statistic right there, and then the p-value there. So you're going to do that not for this example data, but for the actual ACT versus percentage of grads and year versus percentage of grads. And then you're going to do that 2 times. So then this is redoing all the same steps again. Anova table, what's the regression line, state correlation coefficient, and then fill in your values.